Stoichiometry problems. The area of chemistry that deals with quantitative relationships among reactants and products is called stoichiometry. And solving problems in stoichiometry requires the use of moles in the form of mole ratios. And what is a mole ratio? It is the ratio between the number of moles of any two species involved in a chemical reaction. For example, if we look at this reaction, hydrogen gas reacts with oxygen gas to form water. And then let's balance this equation. So here, this in this equation, we can see the mole ratio. We can see the quantitative relationship between reactants and products. 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to produce 2 moles of water. So that's what quantitative relationship is. Now, this table here is very important, and if you will understand this, you're not going to have any problem with these stoichiometry questions. And if you look at this, for example, you can go from moles of A to moles of B just using the mole ratio, which is one step process. If you are given grams of A and you have to find out moles of B, then first you have to convert grams of A to moles of A, and then you go from moles of A to moles of B. Let's say if you are given molecules of A and you want to go to grams of B, you first convert molecules of A to moles of A, then using the mole ratio from the chemical equation, you convert moles of A to moles of B, and then you go moles of B to grams of B. And we have already discussed in the previous video how to convert moles to molecules or molecules to moles, which is by using Avogadro's number. And we also went over how to go from moles to grams by using molar mass. These were my last 2 videos. So let's do a few problems. I have this table on each and every slide so that you do not have to go back. How many molecules of oxygen will be required to produce 1.60 moles of water? Now what is given to you? 1.60 moles of water is given to you. So let's assume your water is A. So here your A is water. And what do you have to find out? Molecules of oxygen. And let's assume oxygen is B. And what do you have to find out? You have to find out molecules of oxygen. So you're given moles of A and you have to find out molecules of B. So what we're going to do, first we're going to convert moles of A to moles of B, and then we're going to go to the molecules of B. So moles of A is water. You write down that first. 1.60 moles of water. Draw a line, put 1. And you have to go from moles of A to moles of B. And what is B? Oxygen. So in the denominator, you're going to write down moles of water. Why? So that you can cancel them out. And here will be moles of oxygen, because B is your oxygen. And where do you find this moles ratio or moles relationship? From the balanced chemical equation. What's the coefficient of H2O? 2. So you put that here. What's the coefficient of oxygen? The number written in front of oxygen. No number means it's 1. So we got this mole ratio from the balanced equation. Moles of water cancels out with moles of water. And then we're going from moles of oxygen to molecules of oxygen. Moles of oxygen to molecules of oxygen. And 1 mole of oxygen means how many molecules? 6.022 times 10 to the 24, which is an Avogadro's number. And then this cancel. So 1.60 times 6.022 times 10 to the 23rd divided by 2 will be the answer. So if you solve that in the calculator, you will get 4.8184 times 10 to the 23rd molecules of oxygen. Now look at the question and look at the number given in the question, 1.60. How many significant figures are in this? 3. So your answer should have only 3. So your answer will be 4. Let me write it down on the other side. 4.82 times 10 to the 23rd molecules of oxygen, which is answer A. Let's do another problem. Here the question is, what mass of carbon dioxide is produced when 3 moles of oxygen reacts completely in the following reaction? So now first thing first, what is given? Moles of oxygen is given. So assume your oxygen is A and moles is given. So moles of A are given. Whatever is given, assume that as an A, and whatever you have to find out, assume that as B. So carbon dioxide will be B, and you have to find out mass of carbon dioxide, which means you have to find out, mass means grams. You have to find out grams of B. B is carbon dioxide, A is oxygen. So moles of oxygen are given and you have to find out grams of carbon dioxide. So how many steps? First, you go from moles of oxygen to moles of carbon dioxide. Then you go from moles of carbon dioxide to grams of carbon dioxide. So let's write it down that. So 3 moles of oxygen. Then we converted moles of oxygen to moles of carbon dioxide. Where are we going to find this ratio? Mole ratio, you can always find it from the equation. What's the number in front of oxygen? 1. And what's in front of carbon dioxide? 2. Moles cancel with moles. And then moles of carbon dioxide, and here will be grams of carbon dioxide. And 1 mole of carbon dioxide equals to how many grams? How do you find out grams? How do you find out molar mass? You add all the atomic masses. Carbon atomic mass is 12, oxygen is 16, but then there are 2 oxygens, so 16 times 2, 32, so total is 44, so 44 grams. So 3 times 2 times 44, and when you're going to do that, you're going to get 264 grams of carbon dioxide. 3 significant figures in the question, 3 significant figures in the answer. Your answer is B. Let's do one more problem. How many grams of oxygen? So how many grams of oxygen are required to produce 1.23 times 10 to the 24th molecules of water? So what is given? Something is given about the water, and molecules of water are given. So let's say water is A, and what do you have to find out about? Something about oxygen. Oxygen is B. So molecules of A are given, so this is given, and you have to find out grams of B. So how many steps? Step 1, step 2, and step 3. So how are we going to write that down? So first, you always start with the number that's given to you in the question. So 1.23 times 10 to the 24 molecules of water. Now from molecules of water, I'm going to moles of water. So in the denominator, you write down same thing. And what do you write down on the top? That what do you want to find it out? So moles of water. And what's the relationship between moles and molecules? 1 mole of water equals to 6.022 times 10 to the 23rd molecules of water. And then this cancels out. From moles of A, you're going to moles of B. And so from moles of A, you're going to moles of B, and B is oxygen. Find these numbers. In front of H2O is 2, in front of O2 is 1. This cancels out. From moles of B, you're going to grams of B. Moles of oxygen, grams of oxygen. And 1 mole of oxygen equals to how many grams? Now oxygen atomic mass is 16. There are 2 oxygens. 16 times 2, 32. So 32 grams. So this cancels out. What is left? Grams of oxygen are left. So 1.23 times 10 to the 24th times 32 divided by this Avogadro's number and 2, and when you will do that in your calculator, you're going to get 32.6747 grams. Now go back to the question and see how many significant figures are there. 1, 2, 3. There are 3 significant figures given to you in the problem, so you have to report 3. So 32.7 grams, because 6 after 6 is 7, more than 5, so you increment 6 by 1. So that will be the answer.
Made with Doodlecast Pro.